Imagine 150-ton flying gas stations cruising silently over a desert, just a few feet apart. Now imagine one tiny mistake, a gust of wind, a throttle slip, or a split-second misjudgment, and suddenly a massive military aircraft loses part of its tail mid-air. Yeah, that is exactly the mystery investigators are trying to solve after a shocking crash involving the Boeing KC-135 Stratotanker over western Iraq. But here's the real question: did the tanker crash because of an accident, a formation mistake, or was it actually shot down? Today we're breaking down what happened, how aerial refueling works, and why these aircraft are the lifeline of modern air warfare. On March 12, 2026, tragedy struck in the skies above western Iraq. According to early military reports, a U.S. Air Force aerial refueling aircraft crashed while operating in what was considered friendly airspace during a mission supporting Operation Epic Fury. The aircraft involved the legendary Boeing KC-135 Stratotanker, a jet designed to refuel other aircraft mid-air. But here's where things get wild. Flight tracking data suggested two KC-135 tankers were flying in tandem when something went terribly wrong. One tanker crashed into the Iraqi desert. The second aircraft immediately declared an in-flight emergency and began circling before making a desperate but successful landing at Ben Gurion Airport. When photos of the surviving plane surfaced, experts were stunned. A massive portion of its vertical tail fin was completely sheared off, and that kind of damage, it almost always points to a mid-air collision. To understand the crash, you first need to understand why these tankers exist. The Boeing KC-135 Stratotanker is basically the fuel backbone of the U.S. Air Force. Without it, many combat missions simply cannot happen. Modern fighter jets like the Lockheed Martin F-35 Lightning II and General Dynamics F-16 Fighting Falcon Dawn T carry enough internal fuel for long-distance missions, especially when operations stretch across thousands of miles. So tankers act like airborne fuel stations, meeting aircraft in the sky and transferring thousands of pounds of fuel while both planes are flying at hundreds of miles per hour. And when stealth bombers like the Northrop Grumman B-2 Spirit are involved, tankers become even more critical. Because without mid-air refueling, those bombers can't reach distant targets and return safely. The first and most likely explanation investigators are considering is a refueling accident. During tanker-to-tanker refueling, the receiving aircraft must fly just a few feet below the lead tanker's tail. That's insanely close when you consider each aircraft weighs around 150 tons. A specialized operator called the boom operator controls a telescopic fuel boom that connects the two aircraft. But here's the terrifying part. The margin for error is basically zero. If the receiving aircraft adds a little too much throttle, hits unexpected turbulence, or drifts forward slightly, it can slam directly into the lead aircraft's tail. At those speeds, even a minor contact can rip off control surfaces or destroy critical structures. And if that happened here, the surviving tanker's missing tail section suddenly makes a lot more sense. Another possible explanation involves tight formation flying at night. In high-risk combat environments, tanker aircraft sometimes fly with lights off, radios minimized, and radar silent. This tactic helps avoid detection by enemy air defenses, but it also makes flying extremely difficult. Imagine piloting a massive aircraft in darkness while staying perfectly aligned with another plane only a few hundred feet away. If a pilot becomes disoriented during a turn, especially at night, the aircraft could drift slightly off course. And in tight formations, that small drift can lead to wing clips, tail strikes, or catastrophic collisions. History shows that many tanker collisions happen exactly this way, not because of bad pilots but because the conditions are brutally unforgiving. When the crash first happened, some analysts suspected something far more serious: a surface-to-air missile attack. Groups aligned with Iran have operated in parts of Iraq, raising concerns that one of them might have targeted the aircraft. But officials from United States Central Command later stated that the crash was not caused by hostile fire. That statement significantly reduces the chances of a missile strike. Instead, investigators believe the damage pattern and flight data strongly support the mid-air collision theory. Still, the final conclusion will likely depend on flight data recorders and wreckage analysis. So why were these tankers operating there in the first place? The answer lies in a major strategic shift. If regional bases become politically unavailable, U.S. forces sometimes have to launch operations from much farther away. places like Greece, Cyprus, and Bulgaria. That dramatically increases flight distances. And distance is the biggest enemy in aerial warfare. To solve that problem, the military deploys dozens of tanker aircraft to create what is essentially a fuel bridge in the sky. Strike aircraft launch from distant bases, meet tankers mid-flight, refuel, continue their mission, then refuel again on the way back. Without these airborne tankers, long-range operations involving aircraft like the Northrop Grumman B-2 Spirit simply wouldn't be possible. Large-scale air operations are like a massive airborne puzzle. You have stealth bombers penetrating defended airspace, fighters escorting them, electronic warfare jets jamming enemy radar, destroyers launching cruise missiles, and tankers constantly feeding fuel to everyone. Even aircraft like the McDonnell Douglas F-15E Strike Eagle may carry huge weapon loads but still rely on multiple refueling stops during long missions. Each of these moving pieces must arrive at the exact right place and time. And when something goes wrong inside that complex system, the results can be devastating. Right now, investigators are still analyzing exactly what caused the KC-135 crash over Iraq. But based on the available evidence, the most likely explanation is a tragic mid-air collision during tanker operations. It's a powerful reminder that even with the most advanced aircraft and highly trained crews, aviation, especially military aviation, still carries enormous risks. And when those risks involve giant flying fuel tankers, even the smallest mistake can turn into a disaster. If you enjoy deep dives into military technology, aviation science, and real-world defense strategy, make sure to subscribe and turn on notifications. Because the skies might look calm, but behind the scenes, some of the most complex engineering operations on Earth are happening miles above our heads. And we break them down right here.